Hello, my name's Andy McElroy and I'd like to talk to you about time. This is the fourth in a short series of talks exploring a theory of time that envisages two dimensions of time. And we've worked through in the previous talks how this can help explain some simple things we see around us, such as matter and antimatter, why there's no antimatter in the world that we see around us. In this fourth talk, I'd like just to talk about Einstein's theory of special relativity and how you can derive a lot of the equations and actually understand relativity a little bit more intuitively by assuming two dimensions of time. So I'm just going to take you through some of the basic ideas first. So we envisaged that everything in the universe, and represent this by our bottle of rice wine here, is travelling in a four-dimensional space-time, three dimensions of space, one dimension of time. And that the other thing we postulated was that in that four-dimensional space-time that the everything, including light and matter, is moving at the same constant speed, the speed of light. So we simplified things just to visualize it. We got rid of two space dimensions. We just envisaged one space dimension over here so that we could then envisage this extra dimension of time. We can't normally see the time, this extra time dimension, only its consequences. We just see things moving in space and changing. But for the purposes of this discussion, we can envisage everything travelling through space and through time. And to help us envisage that constant speed, we have our Christmas wrapping paper. And the Christmas wrapping paper represents that speed. So if our bottle of rice wine is stationary, then it's moving through time. So it's stationary in space, it's moving through time at this constant speed of light. And as it starts to move through space, then it has some motion through that space direction, and as it gets to the speed of light through space, then it's not moving through time at all because it's got this constant speed. So, and then there's everything in between. And so in order to derive the equations of special relativity, and how time gets contracted, for example, you can use Pythagoras' theorem. So envisage the situation, the quite simple situation, when the bottle of rice wine is travelling at the same speed through time as it is through space. So this is then moving in a diagonal through space and time, so it moves in this diagonal course with an equal speed in both. Then we can use Pythagoras' theorem to calculate just how much slower through time we perceive this rice wine to be travelling. So when it's stationary, it's travelling at this normal rate of time change, but as it gets faster through space, that dimension gets shorter, and you can calculate this by Pythagoras' theorem. So this square on the hypotenuse, this is constant, speed of light, so c squared, the square of the hypotenuse, is equal to the square of the velocity through space plus the square of the velocity through time. Then you can just rearrange the equation and you get the speed through time as being the square root of c squared minus the velocity squared through space, or the contraction is the normal speed c minus that. That's how much slower it's going through time. So you can calculate these simple time contractions just by envisaging the extra time dimension as a normal dimension like any other, and then just using Pythagoras' theorem to calculate the contractions. Reasonably straightforward. Is it true? Well, I think it's easier to visualise, I certainly find it. And I think probably a lot more maths needs to be done to determine if there's any really validity to this, or whether it's just an easy way to think about things. I certainly find it helps. Right, been nice talking to you.